is really just kind of graph analysis. We're going to talk about graphing a power or radical function, and then you're going to have to state all of the graph analysis stuff about it. Okay? You get to use calculators. You definitely need a graphing calculator right now. All right. Oh dear. Math team is starting up very soon. I have a save the date flip that if you remind me, I can give you that tells you when the 3 contest dates are. Okay. Practice is starting not next week, but the following week. So we'll spend more time talking about that another day. Yeah, I'm just moving on because I don't have time to talk about all this. What? Oh, those are warm-ups. Okay. So real quick, how would we solve A? Anybody know? This is my warm-up problem A right here. Yes. Oh. I always. Anybody get number 1 done or A? No ideas? How do we solve this? Add the 7. So we have the 4th root of x plus 1 equals 10. Yeah, each side needs to be raised to the 4th power. So we get x plus 1 equals 1 with 4 zeros. And then subtract 1. Okay. This one is going to be really important today. To square this, okay, everybody paying attention? You have to multiply this times this. What is that going to give you? 2 square roots of x times 2 square roots of x. 4, just x. Because square root of x times square root of x is the square root of x squared, which is just x. We okay? All right, then would I do the middle term here? I get what? Square roots of x. This one is also negative 6 square roots of x. And negative 3 times negative 3 is 9. That simplifies. I have a 4x, a negative 12 square roots of x, and a 9, and that's it. Okay? We'll go from there. All right, that was the warm-up for today. Chapter 2, Section 1, we're at. Power functions, okay? A power function is anything that can be written ax to the n. So negative 3x to the 7th, 1/2 x to the negative 4, okay? They can be positive or negative powers of x. All right, if the power is even, so we have a degree 4, we have like an x squared, an x to the 4th, etc. It will be this shape. As long as it's positive, if the coefficient is positive, if the coefficient is negative, it opens down, okay? And we have talked about all of these things before. This graph is continuous. It has an intercept at 0, 0. It has y-axis symmetry, the domain and range. Domain is all real numbers, increasing, decreasing. I don't think those are going to throw you off too bad. These we have also kind of already talked about because we've done x cubed, x to the 5th, etc. If it's positive, it's going to open, it's going to start in quadrant 3 and end in quadrant 1, or whichever if you're going left to right. And if it's got a negative coefficient, it's going to flip around. But nothing is confusing about domain and range or increasing, decreasing there. When we start talking about negative exponents, then we're going to get some continuity concerns. All right, so I'm thinking I don't even need to talk about this one. You would plot some points, okay? We're not going to be real super accurate today on sketching these, by the way. All right. Monomial function. What does monomial mean? It's only one term. So like 6x squared. There's no plus 3x minus 5 on the back. It's one term. Monomial functions with an even degree are also even, and monomial functions with an odd degree are also odd. In other words, if we don't add a bunch of other terms, they're going to have some kind of symmetry, even or odd. All right. Graph each function, describe domain, range, intercepts, and behavior continuity where the function is increasing or decreasing. All right. Graph this on your calculator. Give me about 3 ordered pairs if you can. 0, 0. 1, 3. Negative 1, 3, and that's about it, right? It looks like a parabola. The only difference you might be able to tell if you graphed a parabola and this is it's a little bit flatter at the bottom. Probably on the calculator wouldn't be able to tell much. All right. Domain, range, intercepts, end behavior. I'm going to practice it this way because that's the way it's on the quiz this week. Next week, just kidding. Continuous and increasing, decreasing. All right, these are all the things at once. Can anybody tell me domain and range? Is there a radical or an x in the denominator? So domain is? Okay. I think it's number 1 on the notes, isn't it? Got it? Range, guys. Range will help if you look at the graph. What's happening with the range? Lowest to highest. Okay, 0 to infinity, but I need a square bracket. Okay. It hits 0. The intercept, only place it crosses either axis is 0, 0. All right. Both f of x's are asking about y values. Both y values, left and right, are going what? Up. So we could just put these both as positive infinity. And then here you need to say the left side and the right side. So one is positive, one is negative. Doesn't matter which. Is this continuous? Are there any holes, gaps, asymptotes, discontinuities? No. So it is, yes, it's continuous. Sorry, I asked that in a very complicated way. Increasing. If I start at the left and go to the right, where is it increasing? And decreasing? Okay, so these are x values, everybody good? Where y is going up, right? Any questions? All right, a reciprocal function is anything that can be written as a over x, which means it could be ax to the negative something. Okay. But these will have discontinuities. Anything you have an x in the denominator, there's going to be an asymptote or an undefined place of some kind. So, number 2 is 1/5 x to the negative third, or 1/5 times 1 over x cubed, or 1 over 5x cubed. Those are all equivalent, just so we're clear. Okay? You can type it in the calculator as 1 divided by 5 times x to the negative third power. It's fine. I am thinking that you get a branch here and down here. How did I do? Okay. They're not accurate at all. Is there even any nice ordered pairs? If there aren't, are there? Now, let's talk about what this looks like on the calculator, though, because students get this wrong. I'm super lenient on the sketch here, okay? I don't care what the sketch is, except it cannot end, guys. This was 1/5 x to the, what was it, -3? Okay, in a standard window, this is what it looks like. It's really nice on my calculator because you can see that it doesn't end. Do you see what I'm talking about out here? It also does not go straight. If I do trace and I go to the left, does the y value ever stop changing? No. It's not perfectly straight, okay? It's getting closer and closer and closer and closer to 0. The same thing on the right. All right, so my graph is really pretty crummy because it should be super close to those, but I don't really care. But it doesn't stop. That's what I need you to understand, is that it has arrows. On the older calculators, it looks like it stops, right? Because you're all in black pixels on your screen, so you don't see where it's running along the x-axis. So make sure you know it doesn't stop. All right, domain, anybody? It's not all real numbers anymore. What's true? What value can it not equal because there's an x in the denominator? Okay, so if we're writing that in interval notation, it says everything up to 0 but not including 0. Range, bottom to top. No. There's a gap. Where's the gap as you go bottom to top? Yes. So it's -infinity to 0 and 0 to infinity. And that's what everybody does, is they just put all real numbers. They forget that there's a discontinuity going up and down and one going across, okay? So the intercepts, does it cross either axis ever? And there's going to be some on the quiz that are none. End behavior. Oh, this is tricky too. I'm going to use Y because I'm lazy. Okay, so if x is -infinity, that means here's the x-axis, I'm going to the left. As I move to the left along this graph, what is it getting closer and closer to? 0. X approaches infinity means as I travel along the x to the right forever, what is the top one getting closer to? 0. Okay, the y value is getting closer and closer to 0. When you get to calculus, you'll talk about it's approaching from above or below or whatever, but we just want to say 0. All right, continuous. Is it yes or no? No. Has an asymptote or horizontal and vertical? Yes. No. So your question is, because that's not end behavior, okay? End behavior is on the far left and right. What's it doing? You're describing what it's doing near the x-axis. As the x is getting closer to 0, from the right, it's going up. From the left, it's going down. I totally get what you're describing, but you're talking about what's going on here. End behavior is what's going on the far left and far right. Better? Okay. Increasing and decreasing. This is hard because it doesn't really look, you have to just kind of make a generalization. Okay, over here, remember it was real close to 0. It's getting a little further away from 0, a little further away, and going this way. So basically just overgeneralize, it's doing that, right? And over here, it was a big value. As you were on this side of 0, it was a big value. Then it was getting smaller and smaller and smaller, and here it keeps getting closer and closer and closer to 0, which is smaller and smaller. So what's it doing? Yeah, both branches are decreasing, but that means it's never increasing. And how do you say decreasing? Careful. Yes, negative infinity till x value of 0, and then again from 0 to infinity. The entire domain, it's going down. What is this? Rational exponents. Okay, so this is when we have fractional exponents. We talked about this yesterday. All right, a radical function is a function that has at least one radical expression containing the independent variable. So 2 times the 4th root of x cubed is a radical function. Just means it has a radical in it. So you can write exponent form. We did this yesterday, right? We talked about which variable went inside and which variable went outside. Am I good? All right, when you graph a radical function, if the indice, the little number up there, is even, you will only get a positive branch. If it's odd, like a cube root, you will get 2 branches. All right, this is continuous, and this one is continuous from 0 to the right only. This one has no symmetry. This one has odd or symmetry with the origin. This is always increasing and only from 0 to infinity because it only has a branch. This one is always increasing as well, actually from negative infinity to infinity. All right, so let's try, let's try this. Is it a cube root? Okay, a negative. And then I'm going to do this differently. It's the same thing. You can use the cube root button, but I hate using the cube root button. It's 2x plus 5. Oops. To the, anybody know what power I could put in for this? Almost, because it had something in here, right? It's 2/3. So it's the opposite of 2x plus 5 to the 2/3. You don't have to put it in that way. Do you need me to show you that it's the same thing? The other option would be go to math, down to number 4. Oh, I should have had a negative up front, huh? No. Oh my goodness. Start over. Cube root of, I would need a parenthesis in here, I think. I don't know. Yes, I do. 2x plus 5 quantities squared. All right, did everybody get one or the other of those in there? I'll show you. Mine's going to do the blue, and then it's going to come back and do the red. They're the same thing. All right. How are we going to find that intercept? What? No, we have to do all kinds of stuff. But it's kind of hard to find a 0, I think, with the 0 function here, isn't it? Because it never crosses. So if you say it's between like -3 and -2, it's going to tell you it doesn't have a sign change. Oh, mine found it. Did yours say no sign change, or did it find the 0? Sometimes it says no sign change. But we can talk about how you would do that without your calculator. All right, it was down here, right? Is it looking like this? Yeah, it has an intercept where this equals 0. So we get x equals negative 5/2 or 2.5. All right, but let's go through the rest. Domain, range, intercepts, end behavior. Increasing and decreasing. Did I get the whole list, guys? All right. Oh, continuous. Thank you. Good job. All right. Domain, anybody? Yeah, it is all real numbers. The reason it's all real numbers, because it's a cube root, you can take a cube of anything, negative or positive, right? Okay. It's a square root, it's a different story. Okay, the range, bottom to top. Okay, except we got to go the other direction. Bottom was negative infinity up to 0, and it did hit. Yeah, mine looks like it's not, but it does eventually keep going more and more down. I didn't draw it very well. Intercept, the only intercept was at negative 2.50. We talked about that. Okay. As I go left, so that would be x is negative infinity. As I go off to the left, this is doing what? Yeah, the y values are getting more and more negative. As I go to the right, the y values are getting more and more negative. So both ends are going down slower than we are used to, but they're going down. All right, increasing, decreasing. Anybody? Yep, it's going up and then it's going back down. You go left to right, remember? So it's increasing from negative infinity till negative 2.5 and decreasing from negative 2.5 to infinity. And it's not increasing or decreasing at any particular point, so you always use parentheses with those. Is this continuous? Yeah. I think yes, because there's no holes. There's a sharp turn, but I think that's still called continuous. I know it is. Okay, I can't write yes, though. Struggle. There was no holes or asymptotes. So every value was defined from negative infinity to infinity. All right, this says watch out. The domain and range has restrictions if you have an even function. All right. Like radical functions, a radical equation. Oh, so we didn't do a radical. Do you want to do like a fourth root real quick? Okay, we'll just keep going. We can do one as a warm-up next week or something. Like radical functions, a radical equation is any equation in which a variable is in the radical, has a radical, is in the radicand. So this is the steps, guys. First, isolate the radical, if you can. Then raise each side to the equation to the power that will get rid of the radical. But whenever you raise each side to a power, there can be an extraneous solution. And all that means is a solution that does not work in the original equation. Students are forever, I don't get this extraneous solution thing. It's a really big word, guys. It just means it doesn't check in the original equation. Anytime you square both sides, you should check. Ooh, this is totally disgusting. Okay, just watch. Don't do this one. You don't have this one. There's no way to isolate the radical, but you want, anytime you have two radicals, you can't get one all by itself. You want to put them on opposite sides. And I could show you why, but it's even more painful than what I'm going to do here. Okay, so I'm going to square both sides. On the right side, squaring it means I'm multiplying it by itself, so I just wrote it out that way so it'll be easier. Okay, when I square the square root, this is taking care of the whole thing, right? And I just get x minus 2. Help me foil this disaster. 5 times 5, okay? Then 5 times this mess would be negative 5 square roots of mess. Inside here, I'd have what? Another negative 5 square roots of mess. And when I when I do negative square root of this times negative square root of that, I get a positive 15 minus x. All right. Now, we're back to step 1. We have to isolate the radical because you're going to have to do this all over again on this question. So, I need to, 25 and 15 is what? It was 25 plus 15, I think. That's 40. And it was a positive 40 on that side. I guess I'll write this step out. And we had a minus x. And what, can I combine those? What does that become? Negative 10 square roots of mess. All right, now what? Remember I said I got to isolate the radical. So I'm going to add an x and subtract a 40 over here. So I get 2x minus 42 equals negative 10 square roots of 15 minus x. Can I divide everything by 2 just to make it smaller numbers before I square it again? If I divide everything by 2, I now have x minus 21 equals what? Negative 5 square roots of mess, because this doesn't go anywhere. I could. You want me to do that? It doesn't matter. You'd have to put this whole side over negative 5. Okay? Yep. Now I got to square it. Both sides. Do you want to cry yet? I do. Stop. Why won't you? There we go. Okay. What's the right side become this time? 15 minus x. Okay. The left side, the denominator is 25, which I think we're going to end up multiplying back over to the other side, but square the top. X minus 21 times x minus 21 is x squared minus a 21x minus another 21x plus 441. Somebody help me. What's 21 times 21? 441. Okay. Now I think we need to multiply the 25 back over to the other side. So this side is going to be x squared minus 42x plus 441. So what's 25 times 15, guys? 225 times 5, I don't know. What is it? Okay. Minus 25x. Is everybody okay with what I did there? I distributed it over to that side. Okay. Has a squared. What do we do when we have a squared? Complete the square, factor, quadratic formula. Okay. But any of those, it has to be what? Equal to 0. Well, I guess not completing the square, but add 25x over here and subtract 375. So we get 0. Okay, someone help me. What is negative 42 plus 25? Is it 17? And 441 minus 375? Okay, factors of 66 that make 17. Minus 6, minus 11. So we get x equals 6 or 11. Okay, we got to go back to the very beginning. Okay, if I put in a 6, it would say square root of 6 minus 2 would be 4 equals 5 minus square root of, I put in a 6, this would be 9. That would say 2 equals 5 minus 3. Is that true? Yes. Phew. Okay. The other one was what? 11? Yeah. Okay. 11 minus 2 is 9. 5 minus 15 minus 11 is 4. So I get 3 equals 5 minus 2. Does that work? Yes. Okay. They don't always both check. Okay. Hereby solemnly swear that that's not on the quiz. Okay. I'm going to come back to those. Let's do the ones you have, and then if I have time, I'll show you another icky one. What do we got to do here? Add the 6. We always think with our Algebra 1 brain first and isolate all of this. So we get 2. Then what? Cube both sides. So we get x squared minus 1 equals 8. Add 1. And we take the square root. What do we have to remember? Positive. Plus or minus 3. Now, are they both going to work? Well, if I square 3 or negative 3, either one will give me what inside here? 9. So I'd have the cubed root of 9 minus 1 minus 6 equals negative 4. 9 minus 1 is 8. Cubed root of 8 minus 6 is negative 4. Cubed root of 8 is 2 minus 6 equals negative 4. Okay, they both work. Number 5. Square both sides, and it's going to be a happy moment because everything goes away and we get 6n minus 3 equals negative 15 plus 7n. Let's see if I add 15 over here and subtract 6n this way, would that be okay? So I'd have what, 12 equals n? Okay, so if I plug it back in, I'd have this. All right, this is 69, and this is 69. So I don't know what disgusting decimal it is, but the square root of 69 equals the square root of 69, right? Yeah. So it's working. All right, number 6. Now they're getting a little more complicated. How do we isolate the radical? So 4x minus 21 equals square root of 56 minus x. Now what? We have to square both sides. Okay, so this side is 4x minus 21 times 4x minus 21. And then the right-hand side is just 56 minus x. Okay, 4x times 4x, 16x squared. This would be a negative 84x. And another negative 84x. Plus what? Negative 21 times negative 21 is 441. Okay. Has a squared, so that's our hint that we need to isolate, or we need to get it equal to 0, right? Okay. So we're going to add an x over here and subtract 56. And I'm just doing it all at once. Okay. So I have a 16x squared. What's negative 84 minus 84 more plus 1? Negative 160 what? 7 maybe? Because we had that 1x we added over from the other side. And 441 minus 56, somebody? Okay. Are those all divisible by 16? No? Okay. Okay. Anybody want to cry a little? Want to do quadratic formula? I don't even know. If we try, what are factors of 385, first of all? 5 times what goes into 385? So 7 goes into 385. How many times? How do I know 7 goes in there, guys? Because if it was 77, that's 7 times 11, right? 11 will also go in there. 7 times what is 385? And 11 times, what was it, 35? Okay, there's some factors, not all of them, but some. I don't know. 4 and 4, 8 and 2, what do you want to try? I think quadratic formula would have been faster. Okay, quadratic formula would say 167 plus or minus the square root of 167. It's negative, I know, but when you square it, it's going to become positive anyway. Minus 4 times 16 times 440, or 385. Okay, someone just do underneath here. What's 167 squared minus 4 times 16 times 385? I got 3249, which square roots to become 57. Did anyone get? Anyone get square root of 3249? Under there, and then square root is 57. Okay, so 167 plus 57, enter, divided by 32 is 7. So it would have factored x minus 7, by the way. 167 minus 57, enter, divided by 32. What? Oh, math, enter, my bad. Somebody help me, I don't have it. 3, 4, 7, 5, math, enter. 55 over 16, anybody? Okay, so, oh, can't wait to check these in the original equation. How about you? Whew. Okay, what are we supposed to be checking? 7. If I put a 7 back in, what's 4 times 7? Over here, I'd have 21 plus the square root of. Minus 7 is 49. 21 plus 7 is 28, yes? Okay. The next one, I'm just going to use my calculator. What was it? It was 55 over 16. So if I do 56 minus 55 divided by 16, math, enter. Oh, I'm supposed to square root that. That's this part over here. Square root of that answer. It's 29/4, okay? So it's 21 plus 29/4. The left side, what's 4 times 55 divided by 16 is 55/4. So does 21 plus 29 divided by 4 give me the same thing? I got that it didn't check. Did anybody else get that it didn't check? So the 55/16 didn't work. Kind of confused why it didn't work. I'll check it again in a minute, but this is the truly ugly one. Do I have 1 minute left? If I add this over here, okay, when I square the left side, I'm just going to get 6x plus 12. When I square this side, I have to write this out. Okay, I get 1 times 1 is 1, plus 1 square root of mess, plus another square root of mess. And when I multiply square root of 4x plus 9 times square root of 4x plus 9, I just get 4x plus 9. So now if I subtract the 1 and the 4x and the 9 all over to this side, I'll have 2 square roots of 4x plus 9 equals 2x plus 2. If I divide everything by 2, I get x plus 1 equals square root of 4x plus 9. Then I have to square both sides again. I get x squared plus 2x plus 1 equals 4x plus 9. X squared minus 2x minus 8. Factors x minus 4x plus 2. So I got 4 or negative 2. If I go back to the beginning, 4 would give me square root of 36 minus square root of 25 equals 1. Is that true, guys? Yeah, that one checks. If I put in a negative 2, I get square root of 0 minus square root of 1 equals 1. Okay, help! Hey, please look. Square root of 0 minus square root of 1 equals 1. Is that true? 0 minus 1 does not equal positive 1, right? So that one doesn't work. Only the 4 works. So your assignment is these problems on page 92. There are 1, 2, 3, 4, 5, 6, 8 of them. Have a great long weekend. Good thing we have an extra day to practice for this test. Well, I'm thinking we're going to need to do some more of these together. So come with homework questions for me on Wednesday. Tuesday and Wednesday, but Tuesday, because some people will miss the review. If I do it Wednesday, I'm going to use the quiz review Tuesday. Yes. But I will video Wednesday if we do some homework questions. Okay. Yep.